Okay, so let's break it down. Let's look at what they were asking you. Let's see what you got, what you didn't, where you could have gotten a few points, and where maybe you lost a few points. So the scoring guide is inside there. So the best thing that I have found to benefit you the most, if you get out another colored pen or anything, just so it's not, so you can really see where you went and what happened. If you don't have one, I mean, it's okay. If you don't have one or you don't want to share, I have one you can borrow if you want. Um, and it really helps you to see because then you can track your progress on where your brain's going and what's happening and what. There was, I won't lie, one C stumped me for whatever reason. I probably would have lost my points there because I didn't read it correctly. But that's okay. But that's why I work them with y'all so I can see where the hangups might be. So let's look at number one first. Remember, always read these problems completely. I know you want to skip down to what they're asking you, but read it through because it'll answer a lot of questions as you go through. All right, so grass clippings are placed in a bin where they decompose. For time 0 to 30, the amount of grass clippings remaining in the bin is modeled by A of T, where A of T is measured in pounds and T is measured in days. And I'm going to try to go quickly so we have time to get through all of them. And then it asks us for average rate of change over the interval, and it also very nicely reminds us to include the units of measure. So there we have a reminder for units, so make sure you do that. This is a one-pointer. You just get 1 point. This is AROC, just straight AROC. That's all this is, average rate of change. Remember, AROC is nothing more than what? Slope. And so if we do AROC, there's not a whole lot of work that has to be shown on calculator problems. In fact, if you look at the scoring guideline, you didn't even have to. I went through on mine and I said A of 0 equals, and I showed where I put, because I am so paranoid about showing enough work. I found this. Remember, 3 decimal places is the minimum. You'll find A of 30 is 0.7829. And so the average rate of change here, I do 0.7829 minus 6.687. If you set it up the way they did, that is fine also. So you get approximately negative 0.19. I did 6.8. They have 7, whichever. But if you don't include the pounds per day, you don't get your answer point. But I would think that they would probably, probably because in the beginning you went back and read in days. T is measured in days. So, yeah, it's probably this. Okay. I would say yeah. I thought they put 0.19. Oh, I got you. Yeah. All right. Questions about part A. All right. Part B. I'm not going to work everyone unless you need me to. But I do want to show you some tricks on using your calculator on these because, again, there's not a lot of work on calculator ones. Let the calculator work for you. So part B asked you to find the derivative. It said a prime of 15. So find the derivative at 15. This was straight on your calculator. There is absolutely no work here. You put a of t in y1 and do your end deriv. That's it. Does everybody remember how to do that? I literally on mine, I put a prime of 15 equals negative 0.1636 pounds per day. That gets you 1 point, just like that. Nothing else, just that. It is a calculator problem, and they expect you to use your calculator on it. You would probably lose that 1 point on it. So I would put a of t into y1, and then I would do end deriv y1 with respect to x, and then you put where you want to evaluate it. So it's 15. You're AFT. No, you're not. No, you're not. Listen, these start to look so familiar. You'll find the pattern. I promise you will, because we're going to do so many. All right, so notice you only get 1 point for that answer. But you also get a point for interpreting. So let's say you got the answer wrong, but you knew what the answer meant. I know, and this is where it's kind of tricky. On day 15, the grass is decomposing 0.1636 pounds per day. You have to say at that, because remember, this is rate of change at a specific time. So at time 15, the grass is decomposing at a rate of 0.1636 pounds per day. um, tell me what you said again. They want you to specifically say there is this much grass decreasing, or the grass is decreasing at this rate at this point per day. That's, yeah. So make sure you completely interpret it. When in question, y'all, it's better to have too much than not enough, because you never know who's going to read yours. I grade these harsher than what I hope the readers would grade them, just because I'd rather have too much than not enough. All right, part C. Find the time at which, this is the one that I messed up on a little bit, because I did not interpret. I started setting up some wonky equation. But read it very carefully. The time t for which the amount of grass clippings, well, amount of grass clippings is A of t, right? Is equal to the average amount. That's your key word. Average amount is average value. How do you find average value of a function? Y'all remember? This is on that little, you'll have one of these for sure. It's 1 over b minus a times the integral from a to b of that function. I did, that's exactly what I did. That's exactly what I did too. I did, but it doesn't say, go back and read it. It says average amount, not average rate of change. I did the same thing. I would have lost my 2 points on this one, because I read it quickly and I didn't read it thoroughly enough, and it says average amount and not average rate of change. So be very, very, very careful. So this was, again, all you have to do is set up your, I don't remember what you get points for. Let's see. 1 point for setting this up with your 0 and 30 in it. So if you had 1 over 30 times the integral from 0 to 30, you don't even have to put the actual function in there, because it's already been defined in the beginning of the problem. You can write it just like that with A of t. You don't have to. I still write it in there because, again, I'm OCD and I want to make sure I get all the points that I possibly can. But if you just write it like that, that's 1 point. And then the answer, which is plugged in your calculator, it's not even, right? Isn't that the one? Oh, you have to set it equal. You have to set it equal. I did go back and work it. So now what you have to do is say, that all it asked you for was average rate? No. This, you find this value, and it wants to know, when does that equal this? Right? So I took, this equals 2.753. So I took this and I set it equal to that original equation and solved it. So when does 2.753 equal this original equation, which was 6.687.931? I put it on my calculator. So I did this. I graphed it and I found where it crossed the x-axis. Any solving one, I use the calculator to solve that way. Set it equal to 0 and find the intercept. So that was a twofer. Part D. Linear approximation at t equals, remember, linear approximation is nothing more than the tangent line. So don't let that wording fool you. I didn't do mine the way that they did. I did find an expression for L of t, but I went through the same way that we normally do. I found the derivative at 30, and that was my slope. negative 0.05598. Again, notice I went more than 3 just because I'm extra. You don't have to do that. And then I found A of 30 because remember I need a point and a slope. And that was 0.78293. And then I wrote the equation of the line. Yeah. Sure. Calculator. Inderiv on my calculator. On calculator problems, I'm using my calculator for everything. Like I literally am just click, 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 click for everything. Not a lot of work here, mostly calculator. And you can expect that on the calculator sections. They want you to rely on the calculator to do these for you. And so then whenever I set up, do y'all remember the inderiv? You know what I'm talking about? And you've still got that function plugged in y1, right? So just redo it, but at 30 this time. Again, it's plugged in here where I did the integral. I just keep referencing that same function. Okay, so I've got my point and my slope. So y minus 0.78293 equals the slope times x minus 30. Now, I did go back. I changed my x's to t's, and I changed my y to L of t because that's what it asked me to write an expression for. So I did solve it for L of t, and I just did this. I said L of t equals all of this plus 0.78293. Then it asked you to, it didn't ask you to evaluate at a certain answer. It says, when will there be, and then what it said, when will there be half a pound of grass? So I said, when does this equal this? And again, I did my calculator. I found where it crossed I set it equal to 0 and found where it crossed the x-axis. $35.054 days. That's what I got. That one was 4 points. That was a big one. For a tangent line, that was pretty nice of them to give you 4 points for there. 2 points alone just for finding the tan line. Even if you did nothing else, just finding the tan line, you got 2 points. And then if you set the equation equal to half, you knew to set the tan line equal to 0.5. That was a point in it. I thought they were pretty generous on the scoring on that one. All right, so out of 9 points, what y'all get on the first one? 1. Thank you for being honest. 3, 2. That's 7. That's impressive. All right, write it on the top though. Don't be ashamed of what you got because they're just going to go up from here and you're going to start seeing. Okay, so don't grade yourself harshly because you'll want to be harsh, but make sure you're correcting as we go. All right, number 2, ready, Freddies? This is just like what we just did. I hope y'all got this one. Henry, don't be late. You're supposed to go. Oh, okay. This one made me sit down and think. Okay, let's see what happened. You can most definitely remember this is still calculator, so there's going to be a lot of calculator usage here. I still label everything on here. As I looked at it, I knew I was going to be doing some type of revolution, and lucky us, we had to do 2. We had to do a cross section and a volume of revolution here. So there was a lot going on. I did miss a part. I set my part C up differently than what they did. I don't know that I would have gotten credit for it. I say yes, but whatever. I did what was asked, just not the way they did. Okay, anyway, it doesn't matter. Part A, find the volume of the solid when R is rotated about the this was the hard part because the horizontal line is all the way down here, right? So I really have to think about my radius of a hole versus a hole. All right, here's my hole. But this is my hole. Okay. I literally put this kind of stuff on my picture so I don't lose my place. It helps me. It helps me go back and see as I lose track of what I'm trying to do. So I'm finding the volume of the solid. I just assumed y'all needed me to work this one. I didn't ask. Yes, okay. All right. So the radius of the whole thing, once you get it labeled, it's a little easier for you to figure out what it is you're doing. The radius of the whole thing is a nice even 6, right? From this line 4 down to the x-axis plus another 2, so it's just 6. The radius of the little hole, however, is a little bit different. I've got to include this 2. And to that, I'm going to add this part. And this part is that equation, okay, which was x to the 4th minus 2.3 x cubed plus 4. I gotta start talking a little faster because I don't run out of time. All right, so now for the area. Remember, this is calculator. It looks very intimidating, but when you remember it's calculator, it doesn't matter how nasty that equation is. I'm just going to plug it in my calculator whenever I'm done. So let's just set it up, and it'll make it a little easier. All right, area of the big hole, of course, 36 pi. Area of the little hole is pi times, and I went ahead and combined the 2 and the 4 to give me 6. X to the 4th minus 2.3 x cubed plus 6 squared. Everybody okay? Volume, I do need that other x bound. I used my calculator. I graphed y equals 4, I graphed y equals bleh, and I found the intersection. Because you need this point, right? You need this point to know where I'm going to set my bound. All right, so my volume, of course, the pi on the outside, I'm going from 0 to 2.3. And I'm doing big hole, 36. Little hole, x to the 4th minus 2.3 x cubed plus 6 squared dx. At this point, I am strictly on my calculator. I put it in my calculator just this way. Multiply by pi in the end. Now, if you look at the answer key, they don't even put the equation in there. I do because. Yes, that's fine. The rule of thumb is if you could, whatever you leave, if you could put it in a normal scientific calculator, in other words, like the little TIs you used to have, if you could type it in there and get an answer, you can leave it like that. So that's fine. Pi, yes, that's fine. That's fine. No units here. We're just rotating a shape here, so we're good. So there you go. 2 points for the integrand set up correctly. That is this. So even if you couldn't get it to go on your calculator, you got 2 points. You didn't even have to put in, if you look at the way they did it, they used f of x for the function instead of writing it out. So you didn't even have to write it out. But 2 points there for that. 1 point if you correctly labeled these. A whole point for that. That's what I say. Don't ever think that you can't do anything on there. Write something. Look, you get a whole point just for knowing. If you just calculate that intersection point and then you went from 0 to 2.3, you got a point on that one anyway. That's pretty good. You get little points here and there all the time. And then the answer itself is, of course, a point. So that one was a 4-point question. That was definitely the meat of the problem here. Part B. Oh, isosceles triangles. Right, but the nice thing about isosceles, right, is that they give us the base and the height are the same, so the area is just 1/2 that value squared, right? Are we all there? Isosceles, same side. So isosceles, so here's how I went about. I said the leg is and I literally, I mean, if I know that I keep saying I literally, but really I draw all over my picture and I use it to really help me because they have an accurate drawing there for you, so let it help you. So I know that my leg, this is the leg, right? So that value is 4 minus, and then I have to take this little bit away. So 4 minus the equation itself, which was x to the 4th minus 2.3 x cubed plus 4. Which means the area of my triangle would be 1/2. The base and the height are the same. Oh. So I'm just going to square this because I know this is a calculator problem. And I know that volume is just the integral of the area. So again, from 0 to 2.3, what's wrong? I forgot it. But yeah, it really just ends up canceling out like this, right? Okay. So now I've got x to the fourth minus 2.3 x. I put that straight in the calculator. 3.574. 2 point. Yep. Sorry. I'm getting in a hurry. So you had this. Mm-hmm. But you didn't get the right answer. Oh, that's weird. Try it again and see. There's got to be, it had to be a problem with a parenthesis or something somewhere in a square. It had to be. I'll look at it right after though. See if we can figure it out. All right, part C. Part C asked you to set up but not solve. By the way, part B you see was worth 3 points. 2 points for the integrand, 1 point for the answer. Always get 1 point just for the answer. I set up part C very differently. I found the area between the two curves to be 3.218. I cut that in half and then I set it equal to the integral with K. This is what I did. I did the area is top curve minus bottom curve, right? I'm still going from 0 to 2.3, and it's top curve minus bottom curve. So 4 minus, and then I did the x to the fourth minus 2.3 x cubed plus 4 dx, and I found what that equaled. And I said, well, that means the area of half of it, the little r, would be 1.609. And so what I did was I said, well, that means from 0 to k of all of this must equal 1.609 because that's half of the value of the whole one. They didn't do it that way. You can look at the way they did it. They set it up. They did this part, but what they set it up to was equaling to from k to 2.3 of that same, would have the same thing in both of these. So I'm not sure how they would score that. If I'm scoring this in class, I'm not giving myself those 2 points because it's not exactly the way they want it. They very well may have given you the point for it. Yeah. This, you would, well, you're not asked to solve it here. You're just asked to set up. But you would be into like fundamental theorem to solve it, where you would find the antiderivative and plug in, you do upper bound minus lower bound, and you plug it in that way and solve for k. It'd be quite intensive to solve that. Oh, gotcha. All right, how many did y'all get out of those 9? Hey, that's good though. That's good. 6. Impressive. Yeah.
I definitely could have gotten to it. I had it in my head.
I gotcha. Nice, y'all. Nice. All right. This one, okay, listen. These are hard because you have to look, you got to look at that graph to see what it is they're giving you. So this says that it's the graph of f. When I read that very first sentence, the function f is defined blah, 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 and they gave me this g of x equals the integral from -3 to x of f of t dt. The very first thing I did before I did anything else was I came up here and I wrote f equals g prime of x, because that's what this is telling you, right? The opposite of integrating is derivative. So this tells me, I think about it like, oh, well, if I just do the derivative of both sides, then g prime of x is going to equal f of x. It's that fundamental theorem, that other part of the fundamental theorem that they're testing here. But you're looking at the graph of the derivative of g. That's where it gets confusing. So once you figure that out, it's a lot easier to work through. Did y'all figure out that this was the graph of the derivative? Okay. All right, part A is just a plug and chug kind of problem. and it is only worth a whole whopping 1 point. It asks you to find g of 3, and for g of 3, since they give you what g equals, you just plug in from negative 3 to 3 of f of t. So all you're doing is finding area of shapes on here from negative 3 to 3. You have two different triangles in that area. You have one big triangle and one itty bitty triangle, and if you plug in, you should find that the area there is 9. Okay, so the area of the first big triangle, right? I got two triangles on. Okay, so here's the line. Draw this correctly. This does this. All right, so I found the area of this triangle and then this little triangle, right? Yeah, they split up. Because this is the axis, they split this into two triangles. Why, I don't know. Silly. I wouldn't have. But 9 is the answer. If you got it, you got 1 point right off the bat. Part B. Now, here's where I'd be really ticked off, because I wrote on my graph, I wrote f equals g prime of x. And look what you get a point for in part B. In part B, you get a point for recognizing that g prime of x is the same thing as f of x. I'm hurrying. My legs are sore too. See, and I did kickboxing last night. Okay. Yes. Okay. All right. On what open intervals are we both increasing and concave down? Y'all know me and my sign analysis. I straight up set up. I'm gonna do it quick. This is what I did. The derivative tells us what the function is doing, increasing or decreasing, right? I'm going between -5 and 4, so I found all the zeros. I'll give y'all a pass if y'all are just a little bit late. I'm sorry, I'm coming. Every place that it crossed, positive, positive, negative. Here's what you have to do, though. You also have to look at the second derivative. The second derivative is the slope of what's going on here. So is it increasing or decreasing? So that also changes. It changes at -3 at 0, because that's the peak of that little triangle, and then on to the end. And you find that it's decreasing, increasing, decreasing. Boop, boop, boop. And you can see your intervals here increasing and concave down. That's how they came up with those intervals. You got, this was only 2 points. Why, I don't understand. But you got 1 point for saying that the derivative equaled the function, and 1 point for your reasoning. Your reasoning being that's where the function is both decreasing and positive. Look through C, because C was straight up nothing more than the quotient property of a derivative, and then you plug in 3. Look at the graph to find those points. And part D was also finding the derivative but chaining it there. So 2 points for chaining and knowing to chain it. If you just want them, you can take them. You can leave them, and I'll keep them here, and we'll keep adding to them. Whatever you want to do. If you didn't finish your correcting this all the way and grading it, take it with you and grade it. What'd y'all get on the last question? Y'all are telling a story. Y'all are telling a story. You got one?